Welcome to the first part of the course on curves on engineering and architecture. In this part, you will be guided by professors Marco Castrillón, Omar Gil, Sonsoles Pérez, and Eugenia Rosado. In this part, we enter the world of the simplest objects in curve geometry, curves, and in particular, we are especially interested in the role that those curves play in architecture. The geometry that you have probably learned at primary or secondary school mainly focuses on the idea of lines and segments. Beginning from them, one then draws more complicated figures as polygons or polyhedra, where one can measure angles, distances, areas, and so on. Perhaps the only concept that may go further is that of circle, or the so-called conics, that is, the circles, ellipses, hyperbolas, and parabolas. All these ingredients, lines and conics, are essential in architecture and represent the main geometric objects in most buildings. But the inspiration coming from nature, the imagination, or the spirit of the artist have always looked beyond and have incorporated other elements that are more sophisticated, lines that are curved and twisted. These are precisely the objects we are going to study in this course, the curves. We put on the screen a poem written by the famous Brazilian architect Oscar Niemeyer. We don't dare to give a translation. We suggest that the student do it. But just let us give the idea of the last two lines. The universe is made of curves. The curved universe of Einstein. Here we have some other of his masterpieces, the Museum in Niterói, again the Museum in Niterói, or the Cathedral of Brasilia. We also show some other famous constructions from other architects, as for example this one of Arata Isozaki and Anish Kapoor, or this one of the Knox Group in Holland. These other two were designed by the architect Anish Kapoor again. But like most objects in science and technology, a mathematical description, a mathematical language is required to work with them. In our case, to work with these objects will mean to code the shapes created by designers, to analyze the properties of the curve, to optimize certain value of the object modeled by the curve, to transfer the information of the curve in an efficient way, or to manipulate the images of the curves with the appropriate software. To do so, we are going to develop three basic ideas. The first one, parameterization of curves, that is, the procedure with which we can describe and draw curves both in the plane and in the space. The second, the notion of curvature and torsion of a curve, going from the intuition of how a curve bends and twists to precise and useful mathematical expression that can be easily manipulated and interpreted. And third, with the previous tools, we will analyze a collection of important curves, some of them very famous, as for example, the Helical Curves, an example of which can be shown in the famous medieval construction on the left of the screen. Or for example, these stairs of Gaudí at the right of the screen, or these other curves, the catenary, again designed by Gaudí in Barcelona at your left. And finally, we will go even further. Based on these curves, we will explore surprising surfaces defined by translations, rotations, or some other techniques. What are the limits of the designer?